Hello class, this is my first attempt at a video lecture. Not going to be a whole lot of lecturing in this one, and I hope to keep the video relatively short. You might call this a State of the Union address. First of all, I just want to urge everybody to stay safe, practice safe hygiene, and just take care of yourselves. Let me know of any extenuating circumstances that you have beyond the obvious, which is that I know we can't come to campus. We all know that. But if there's issues at home with your internet or family problems that are keeping you from doing your work, just please contact me early rather than later. And just stay in touch. I'm on my email quite a bit. And I'll be setting up regular Zoom office hours next week. I'll post that over the weekend or on Monday. I'm thinking it'll be around 11 o'clock to 1 o'clock Monday through Thursday. And if those times are bad for you, just let me know and we'll go from there. So I've set up a little recording station in my house, and I'm trying to mimic what we do in class as closely as possible. So I'm committed to your success. Probably misspelled committed, that's okay. Please keep in contact with me. Email me for Zoom office hours. There's my dog Maggie getting her voice on the recording. That'll be probably common throughout the remainder of the semester. Email me for Zoom office hours, and I'll post regular hours as well soon. Okay, obviously things have changed. What changes are we going to see moving forward with the semester? Changes. Labs, that's a big one. And so this next statement might not make sense. Everything is the same except you will do the labs on Logisim instead of building them. We obviously can't build the circuits, so you will build your circuit in Logisim. Let's see if I can pause the video. No, I cannot. So you're not going to be measuring delay. I put this on the schedule. There's an updated schedule. Look at it. Skip 5-2. So our only two labs left to do are Lab 5-3 and Lab 6. The Logisim circuit must be detailed. So that means pin numbers and chip numbers for all connections. Please feel free to send me your circuit ahead of time and I'll look at it and say this is detailed enough or this is not. So whenever on the schedule it says your lab report was due, that's when your lab report is due. You still do the questions, still should have a pre-lab. all due on live report due dates. If I think of anything else, I'll let you know. If you have any questions, please let me know, and we'll go from there. All right, and I will, of course, as always, be scanning these notes and posting them online along with the video. All right, I think that takes care of it for labs. Labs really should be, also you may work with your lab partner or partners. You know, probably work remotely, depending on what your risk level is and what you think. But I leave that up to your judgment. If you and your lab partners all want to turn in the same Logisim file, that's fine, but you will each need to do your own submission because you each have to answer the questions on your own, and you should all have a pre-lab. Again, work together on the pre-lab. I don't want you to lose the help that your peers give you to the labs. All right, quizzes. These are still individual work. I will post online. You will scan answers / photo with your phone. I'll post early and give you a due date. And really, I can't say that these are closed book. There's no way I can enforce that, and so that's fine. These are kind of turn into just extra homework problems, which will be good for you to practice. So that's now it still should be individual work. Honor code is in effect, but use your notes in your book. Tests. Still individual work. Open book, open notes. I've already completed the tests, but now that things have changed, I may add a Logisim component to them as well. I know a few of you had issues getting Logisim to work. I'll work with you all individually and see what we can do about that. Otherwise, just plan on using Logisim, and we'll see, like I said, individual basis on the rest of you. Let's see what we're looking at time-wise. 9 minutes. I want to get this wrapped up here. So the test, a lot like the quizzes, I'll post it, give you a due date, and you'll work out your answers, and possibly you'll scan some of them. Some of them will be on Logisim, and you'll turn them in on Canvas. Lectures will be like this video. You'll have scanned notes. Something exciting, some new technology. I downloaded something called Duet, which allows me to have my iPad work as a monitor. So I can pull my iPad over and set it down here, and I'm going to demo that in a moment, and we can I can pull up circuits on Logisim and I believe that will actually be helpful moving forward. So scheduling wise, what's coming up? We stopped last 2 weeks ago, I guess it was, right before break. We looked at adders. We are going to skip the carry look ahead adder. You know, we've lost a week of time this week, so skip the carry look ahead adder. We will look at a subtractor now. Next lecture is the decoder. So that's the next one. So I just want to look at the subtractor very briefly. I've built some circuits in Logisim, and that's what we'll do now. So this will harken all the way back to week 1 or 2 of the class. So some review. How do we subtract? And it was the same for signed or unsigned. We complement the second operand, add 1, and then we add the operands. So we need a circuit to do this part. And we looked last time at how to build an adder. So if we can build a circuit that does this, then we can just reuse what we built last time. And that's the whole idea behind the chapter we're covering now with combinational circuits, is we want to take these devices that are a little more complicated than just AND and OR gates by themselves and do interesting things with them. So we need a signal. When I say signal, that means it's going to be a 0 or a 1 to indicate if we add or subtract. We'll say 0 means we're going to add, 1 means subtract, and we will call it A0/S. So this means it's an active low signal. We're adding when the signal is low. That's what this indicates whenever we label something like this. Subtract signal means it's an active high, so when it's a 1, we're subtracting. It's just 1 bit. So 0 we add, 1 we subtract. And that's good because when we are subtracting, we need that 1 to add here in step 2. Now, is there a way that we can also use this 1 to complement the second operand? If you want to, you could pause the video at this moment and think about that for a second. I'm just going to carry on, and we can use exclusive OR. So 1 exclusive OR with X is equal to X naught, and 0 exclusive OR with X is equal to X. So if we run every input of the second operand into an exclusive OR gate, then if it's a 0, we'll get back what we started with for adding, and that's what we do when we added. We just add the 2 numbers. But if we want to subtract, we have to complement the second operand, and here's a way that we can do it in hardware. So next I'm going to bring up my book, This is page 256, figure 5.5, and then I'll show this to you on Logisim. Here's our add, A0/S, 0 for add, 1 for subtract. The first operand, A4 to A1, we just leave alone. Second operand, the B's, we run through exclusive OR gates. If this signal is a 1, we'll subtract. And so that will have the effect of complementing all these and putting a 1 in the CN. And so that will effectively subtract. All right, so I've come up with a demo on Logisim as well. I'll include this file in the posting. So down here, I've got just a plain adder built into Logisim. Here's a 4-bit input. When you click on these inputs here, you can change the number of data bits, and that's how you get to this. Same thing with the output. Now here, I needed to, this is called a splitter, and so I took this 4 bits and split it so I could run it into my exclusive OR gates. Here's my add subtract line, and then I took these and took the splitter and reversed and combined them back to be my input here. With this, you determine how many bits you want to add. So I'm doing 4 bits plus 4 bits. So when I'm at 0, this functions as an adder, and I should be able to get the same answer down here as I get up here. So let's try it. I probably should have tested this ahead of time. 3 plus 3. We know the answer should be 6. And both of them give the same answer. 7 plus 7 should give us 14, 1110. Let's do 8 plus 7 gives us 15. 8 plus 7 gives us 15. All right, looks good. Overflow, 9 plus 7. We now see overflow from addition. Let's do subtraction now. This is 9 and 7. So 9 minus 7 gives us the answer of 2. All I did was switch this. I'm now subtracting. So I've reused this piece of hardware and a little bit of additional hardware, and I've got an adder / subtractor. Over here, this is not an add subtract line. This device is a subtractor, so I don't have to do anything here. 9 minus 7, and I get 2. Let's do 9 minus 9. And do that up here as well. We're using these below to check our results. And we get 0 here also. You can use the carry out bits again to look at overflow. I'm not going to get into all that. I just want this to be a brief introduction. And let's also look here how our input is being complemented. So see here, our second operand is 1001, and we end up with 0110. Count those from the wrong way. 0110. 0100. And so what is this? This is 9 minus 11, which should be negative 2. And we get the same result down here. So that's going to wrap it up. Again, please stay in touch, and good luck. Let's be successful, work hard, and close out this semester strong. Thank you.